So hello everyone and welcome to a new video. So today we are doing solid state and we will be beginning with this. Okay, so first of all we have the characteristics of solid state. So what are the characteristics of solid state? They have a definite mass, volume and shape. Okay, so basically as we know that we learn about the three states, solid, liquid and gas. We've learnt about these three states in our previous classes. So we know that liquids and gases, they are called fluids because they can flow, and solids have fixed positions, so that's the reason they are called solids. Okay, so we will be looking at the characteristics. Number one is that they have definite mass, volume and shape. Okay, definite mass, volume and shape. Number two is that their intermolecular distances are short. So the distance between two particles of any solid, they are pretty short and they are very strong as well. That's the reason solids are solids and they can stay as solids. Hope you understand that. Then we have the constituent particles, which are atoms, molecules or ions. Their constituent particles, they have fixed positions and can only oscillate about their mean positions. Pretty simple. And then next is that they are incompressible and they are rigid. So here in our textbook as well, all of the 5 properties are given just as I wrote there, 3, 4 and 5. Yep, they are all given here. So next up we will be seeing types of solids, which is amorphous and crystalline solids. Okay, so under this is just a pretty simple table that you can understand. We'll first look at this table, then we will also look at the textbook about the structures that are drawn there. Okay, so first of all we have the shape. So the shape of crystalline solids, they have a definite geometrical shape, and amorphous solids, they have an irregular shape. Okay, then the next is that the melting point of crystalline solids, they melt at a sharp temperature, while amorphous solids, they gradually soften over a range of temperature. Okay, next we have the cleavage property, that when crystalline solids, when they are cut with a sharp edge tool, they split into two pieces with plain and smooth surface, but that's not the case in amorphous solids, because when they are cut with a sharp edge tool, they cut into two irregular surfaces, as it's just written. I will show you the structures of amorphous and crystalline solids now. So here as we can see the structures, so right here this is quartz, this one A, and this is quartz glass. So this one right here, this is crystalline, and this is amorphous. So you can just clearly see the difference between these two. Okay, so this is pretty visible to us, that for example when we cut this from this place, it will be like a pretty smooth surface, just that it's seen before. लेकिन हम इसको यहाँ से ऐसे काटेंगे, then this could be irregular. Okay, so next up what do we have? हीट ऑफ फ्यूजन. ओके, सो यहाँ पे हमने क्रिस्टलाइन में देखा कि उसमें बेसिकली स्ट्रक्चर एज वी सॉ इट, so it's pretty visible that it will have a definite heat of fusion, but amorphous will not have. Okay, next up is melting point. I didn't properly say it, but in amorphous it melts at a sharp temperature. So at a specific temperature, the whatever it is, the solid that you are using, it will just melt. But I mean in crystalline, sorry, in crystalline it melts at a sharp temperature, but in amorphous it gradually softens over a range of temperature. Okay, yep, so this is pretty important, so that's why. Next we will look at anisotropy and isotropy later on. Okay, now we have the nature that of this solids. Crystalline solids are true solids, but amorphous, they are either pseudo solids or super cool liquids. And next we have the order in arrangement of constituent particles. So crystalline have a long range order, but amorphous do not, they have a short range order, and that is just what affects anisotropy and isotropy in these cases. So what is anisotropy and isotropy? For that, remember that crystalline are anisotropic and amorphous are isotropic in nature. Okay, So what is anisotropic? Anisotropic means that some of the physical properties, they show different values when measured in different directions along the same crystal, and isotropic means that the physical properties are same in all directions because there is no long range order in amorphous solids. So yep, so right here we have this is a crystalline solid. Okay, so here we have this and this. Yeah, okay, so they are like basically different types of crystals, or well, you can see it. So here in when you go this way upwards, then there is this specific position, but for example you go this way as this line is gone, so this order of crystal, it differs from this order of crystal. I hope you're understanding what I'm saying over here. So in the NCRT they have also given a pretty simple definition of how this works, but this is not the case in amorphous, because in amorphous there is no long range order. This means that there is a long range order because these crystals, they have a specific arrangement over a specific time. Okay, next up we have this difference between amorphous and crystalline. We have just seen this table before, and I guess now we'll be moving on to classification of crystalline solids. I guess it will be easier if I just show it to you in a tabular format. So right here we have that. So first of all, this is classification of crystalline solids. Right here you can see this. Okay, so first of all you have this types of solids. We have molecular solids. Under molecular solids we have non-polar, we have polar, and we have hydrogen bonded. Then second we have ionic solids, then we have metallic solids, and then we have covalent or network solids. Okay, it is simple. So now we will be starting with this molecular solids. So the constituent particles of molecular solids, there's molecules, so it is visible from the name. Then the bonding or attractive forces of this, they are in non under molecular solids we have non-polar, polar, and hydrogen bond. Okay, so in non-polar, the bonding or attractive forces are dispersion or London forces. These are weak, as we know, so that is why its physical nature is also soft, and it is an insulator. Then for polar solids we have dipole forces, and their physical nature is soft as well, and they are also insulators. And under hydrogen bonding we have the bonding force is hydrogen, and their physical nature is hard. Here you can see a few examples. So we know that three of these, they are conductors, but the melting point, it varies as it goes down the table. Okay, so here as the table goes down, the melting point increases. First of all it's very low, then it goes to low, then it goes to high, then fairly high, then very high. So now next up we have ionic solids. Under ionic solids, the constituent particles, they are ions, and the attractive forces are coulombic or electrostatic forces. Okay, their nature is hard, but they are brittle. Okay, then the electrical conductivity is like they are insulators in solid state, but they are conductors in molten or aqueous state. Melting point is high. Okay, example you can just see this here. Next we have metallic solids. Now here under metallic solids, their constituent particles, that they are positive ions in a sea of delocalized electrons. Okay, their bonding is that they are made up of metallic bonding, so the attractive forces. And here we have a few examples: ferrous, copper, magnesium. Okay, manganese, I guess. Yeah. Then next is that their nature is that they are hard, but they are malleable and ductile. So malleable means that they can be beaten into thin sheets, and ductile means they can be stretched. Okay, we've learned this before in previous classes. Next is their conductivity, is that they are conductors in both states, and their melting points are fairly high. Now lastly we have covalent or network solids. So these are basically made up of atoms, and the bonding forces is covalent bonding. Here we have a few examples: quartz and diamond. Down here we have graphite, which is an exception. It is soft and a conductor, but the others, they are hard and insulators, and their melting points are very hard. Okay, so next we will be studying crystal lattice in the next part. Thank you for watching. next part will be, it's just already there. Okay, bye bye.